Hey math kids, today we're going to talk about radians, arc length, and area of sector. So when we measure angles on a circle, a lot of times we use degrees. That's what you're most comfortable with. But we can measure the same angle, pretend like that's the same circle, and that can be pi over 6. So the first thing that I want to talk about is how to convert between one or the other. So if we're given degrees, for example 30 degrees, our scale ratio is 180 over pi or pi over 180, because 180 and pi are the same thing. 180 degrees is pi radians. And so the way that we choose, if we start with degrees and we want to go into radians, we want pi in our answer, and so pi is on top. So we do pi over 180. We reduce this fraction. That's going to be a 6 on the bottom and a pi on top. And so we see that we got pi over 6, like I was saying. Now, if we start with radians, so maybe we start with pi thirds. We want to use the other ratio because this time we want to cancel pi. So we're going to write pi over 3, then 180 over pi. So we have pi thirds and then 180 over pi. And we cancel the pi's. 180 divided by 3 is 60. And so that means pi thirds is the same thing as 60 degrees, just like 30 degrees is the same thing as pi over 6. Now, the benefit to using radians is in this next situation. If we have a circle and we want to take just a slice of that circle, we can find a few different pieces of information. So this piece, like the pizza crust, is going to be called the arc length, and we'll refer to it as S. Don't ask me why, but it's S. Okay, we also need to remember that this is our radius. And then we also care about the central angle, which is theta. Okay. Now, if we're asked to find the arc length is just S equals theta times R. Pretty simple equation. And then if we wanted to know the surface area of a piece of pizza, we could use this one. So area of sector is what it's called. Is equal to 1/2 theta R squared. And we're just going to do both those things for the next situation. So keep those on the screen. We have a pizza. This. While we're eating the pizza, we're like, I wonder what this angle is. We pull out our protractor, and we find out that it's pi thirds, because it's measuring in radians. Once we do that, we also measure the radius, and we find out that the radius is 10 inches. Okay? And then we want to know how long the crust is. And since it's curved, we decide to do some math instead of just measure it however we measured the crust, or measured the radius. So we're going to say S is equal to pi thirds times 10. So that's going to be 10 pi thirds. And we can leave that as our answer, or if we want to see what that is as a decimal, we can go to our calculator and do 10, where's pi? I don't know why I can't find pi. Where the heck is pi? I'm sure you guys can see it right now, but I can't see it. Here it is. Sorry that took so long. Okay, so it's 10.5 if we rounded 3 significant figures. Okay, so the length of, once again, the arc length is what it's called in math, or the length of the pizza crust. It's going to be that. Now, if we want to know the surface area of our pizza or the area of the sector, we have to use this bottom one. So it's going to be area is equal to 1/2.
Alyssa, you're getting checked out. Alyssa, can you come to the front office to get checked out?
1/2 times pi thirds times the radius, which is 10 squared. Okay, so we multiply this. I'm going to multiply these two and do this one. So if I multiply these, I get pi 6. If I square this, I get 100. And if I multiply that, I get 100 pi over 6. Divide those both by 2, I get 50 pi thirds for my area. However, most people can't wrap their head around that, so 50 times pi, what was it again? 50 pi thirds divided by 3, we get 52.4. Now, let's talk about units. So the units on that, since the radius was measured in inches, the arc length is also going to be measured in inches. So that's 10.5 inches. And then the area has 2 dimensions, so we're going to say inches squared. Okay? Let's see if there's anything else we need to talk about. Sometimes you're given different information. So for example, you're told the radius equals 2, theta is unknown, and then s, or the arc length, is equal to pi halves. So if we're trying to find, we want to find theta as well as the area. So we're trying to find area and theta. So let's find theta first. So we're just going to say S equals R times theta. Plug in what we know. So pi halves equals 2 times theta. Divide both sides by 2, which is the same as multiplying by 1/2. So that's pi fourths is equal to theta. Okay, so that's pretty good. Then we're going to use that in the area equation, which is A equals 1/2 theta r squared. So we get 1/2 times our theta, which is pi fourths, times our radius, which is 2, and we square that. So we multiply these two together, we get pi 6. Do 2 squared, that gives us a 4. And so that's 4 pi 6. We reduce that, and it's 2 pi thirds. You can leave your answer like that, or you can change it into a decimal, whatever you like. Okay, let's try one more like that. So this time we don't know the radius, but we know that theta is equal to pi halves, and we know that s is equal to 3 pi halves. We want to know the area and the radius. So we'll find the radius first. We'll say s equals r times theta. We know s is 3 pi halves. That's equal to r times pi halves. So to undo that fraction multiplication, we'll do 2 over pi on both sides. And a lot of stuff cancels, so that's nice. 2's cancel, pi's cancel, so that's just a 3. Those cancel, so the radius is 3. Now to find the area, A is equal to 1/2 theta r squared. And so we get A is equal to 1/2 times theta, which is pi halves, times the radius squared, which is 3 squared. When we simplify this, we multiply these two, we get pi over 4. Square this, we get a 9. So that's 9 pi fourths. Once again, we can just leave it there, or you can change it into a decimal if you'd like. I think that's about it. Let's try one like this, though. So we're given a sector, W, Y, X. We'll say that this is 6 millimeters. We're also told that the central, or the angle WXY, or the measurement of that, is 4 radians. And we want to just know the perimeter of the sector. So we want to add this, this, and this. So since these are both, these green ones that I'm drawing, those are both radii of a circle. Remember, this is a piece of a circle. It's not a very good circle, but it's a piece of a circle. So this is also a radius, so we know that's also 6 millimeters. So the only thing we need to add these 3 sides is the arc length. So I'm going to say S is equal to R theta. We don't know S, but we know that R is 6. And we know that theta is 4. So S is equal to 24. And that's going to be millimeters. So we have 24 millimeters right there. And then if we just add those sides, we get 36 millimeters. So 6 plus 6 plus 24 is going to give us 36 millimeters for the perimeter. If you need additional help, please come to Math Lab. Until then, calculator.